Hello there. Today we're going to be talking about the absolute value function. We know that it's the equation y equals the absolute value of x. Our goal today is to explore the parameter changes to the absolute value function. We're going to look at the general form y equals a absolute value of x minus h plus k. We're going to be seeing this a, h, and k value come up over and over again this year, and today we're going to start looking at what each of those things do. So we first want to start by graphing just y equals the absolute value of x. Go into your calculator. You're going to go to the y equals. To get the absolute value bars, you're going to hit Math, scroll over to where num is highlighted at the top, and we're going to choose the first one, ABS, for absolute value, and then just put your x in there. If you hit the right arrow, that's going to take you outside those absolute value bars. Okay, graph. You can look at your graph. You can also go into your table in order to plot some actual points, so that way you have an accurate graph drawn on your paper. Some things we note is it starts at 0, 0, then it goes 1, 1, 2, 2, 3, 3, same the other direction, negative 1, 1, negative 2, 2, negative 3, 3. So we want to see what happens if we change our equation. So if we change it to y equals the absolute value of x plus 2. If you notice, this plus 2 is outside my absolute value bars, which is very similar up here to the top where we have plus k. So the first variable we're looking at is k. We want to see what k does to our equation. So what we're going to do is go into our y equals, we're going to go down to y2, and now we're going to type this equation in. So math over to num, get your absolute value of x, but notice the plus 2 is outside the bars. If I were to continue typing, it would stay inside the bars. So over to get outside, plus 2, and go and look at your graph. You can see our new graph. It appears as shifted up 2. To verify this, we can go back to our table and see that our point was at 0, 0, now it's at 0, 2. The point that was at 1, 1 is now at 1, 3. Point that was at 2, 2 is now at 2, 4. So all of these points have indeed shifted up 2 units. So after we finish graphing this, which it's always good to graph in a different color, so that way you can see what's happening. Here's a red graph. We know that this shifted up 2 units. So if a plus 2 on the outside shifts us up 2 units, what would you think would happen if we do the absolute value of x minus 1? Take a second and go in and see for yourself. So if we go in and we go down and we change this to minus 1, hopefully you would have guessed that a minus 1, there's your original, would shift your graph down 1 unit, which is exactly what it did. So this would shift down 1 unit. Okay, so now what if I change it up and I say y equals the absolute value of x minus 3? What we want to do is go back into our y equals, come down here, and we're going to clear out this equation, and now we want to type in the absolute value of x minus 3. So math over to num, absolute value of x, but now my minus 3 is inside those absolute value bars, so we're going to hit minus 3, and then we'll hit our arrow to get outside the bars. Your equation in your calculator should match the equation that you have on your paper. Okay, now since we've moved inside, we've changed letters, so now we're looking at the h. We want to see what happens to the h. We saw that k shifted our graph up and down, and now we want to look at h. So when we go to graph this, always graphs our original first. Now my graph has shifted to the right. It appears that my graph has shifted right. So we go back to our table to check some points. Go ahead and plot those in. And when you see your graph has indeed shifted to the right 3 units. Oops, I messed up there. So this is going to move right, or we can say shift really, 3 units. Okay, so a minus actually moved my graph to the right. So what do you think would happen if we had a plus inside? Y equals the absolute value of x plus 4. Hopefully if you see that a minus moved us right, maybe we could guess that a positive would move us left. So if we change this to a plus 4, hit graph, there's the original, there's the other one, and now it's gone left 4. So far we've noticed that when we add a number to the outside, so when we add a plus 2 or a minus 1, our number outside of our absolute value bar shifts our graph up and down. If it was positive, it went up. If it was minus, then it went down, just like what we would think. But when we move to the inside of our absolute value bars, a minus actually shifted our graph to the right. and a plus shifted our graph to the left. So when we're outside the absolute value bars, it goes with our intuition, up or down. When we're inside, it goes right and left, opposite of our intuition. So now let's look and see if we were to graph y equals 1/2 x. This is a multiplier, or a number out in front of our absolute value bars, a coefficient for absolute value, which is our a value. So now we're looking at the value of a. So if we go into our calculator, we go back into our y equals, going to come down and delete that equation again. We want to do 1/2 the absolute value of x. So 1/2 the absolute value of x. New graph. What this has done to our graph is it's actually shrunk our graph. So our graph went from this point here and it shrunk it down. It took it and it literally just squished it down. We'll look again in class tomorrow. I'm going to restrict your domain so that way you can see how it really shrinks. It doesn't flatten, it just shrinks straight down. So we call this a vertical shrink. Whoops, shrink. And this is a factor, and whatever number this is, that's your factor of 1/2. So what happened to your graph is all of your x values really went in half. So if we look at our table, when we had, let's come down here to 2. So our original point was at 2, 2, but when we applied that 1/2, it moved to 2, 1, which was half of the distance. 3, 3 moved to 3, 1/2. So if you see everything went down, our y values were only half as what they originally. So that's why it shrunk. It shrunk them down by half. If we were to change this to y equals 2 absolute value of x, so we're going to go down, we're going to delete that. So we have 2 absolute value of x and graph it. The exact opposite happens. So now instead of shrinking our graph down, it's actually going to stretch our graph up. So we go to our table and we look again. Here where we're at 1, 1, now it's at 1, 2. It was 2, 2, now it's at 2, 4. So it's multiplied all those y values by 2. So it's shrunk. So we call it, it's stretched. I'm sorry. It's called a vertical stretch factor of 2. Okay, the last thing that we'll encounter is if we were to just have an equation y equals negative absolute value of x. We go back in, clean this out. So instead of a 2, we're going to use our negative, make negative absolute value of x, hit graph. Okay, some blue. So if we look at this blue, what that does is that reflects our graph. But since we're in Algebra 2, we don't say flip, we don't just say reflect, we need to tell us exactly what happened. So this reflected across the x-axis. So reflects the x-axis. So to review what's happened, if we have a number, a k, on the outside, that's going to move our graph up and down the same as what we thought. Inside, we'll move right and left, opposite of whatever it is. If you see that minus sign, that kind of helps remind you that it's the opposite direction of what you would think. A value in front will stretch or shrink your graph depending on what it is, and then a negative out front will reflect your graph over the x-axis. So if you want to come back and take this equation, y equals a absolute value of x minus h plus k, sometimes I'll throw the negative in there, you can come through and just label all these pieces. So this is reflect x-axis. Oops, can't see what I'm doing, can you? So we reflect the x-axis. Our A is a vertical stretch. And if we notice, it stretched when we were 2. So this is a stretch when A is greater than 1. It's a vertical shrink when A is between 0 and 1. Sorry for my chicken scratch. H moves it left and right, always opposite of what you think, so this would be opposite of your intuition, and K moves up and down. If you want to remind yourself that it's the same as your intuition, you're more than welcome to.